In this video, we'll look at how to create sprite animations in Corona SDK using an image sheet. If you haven't already, be sure to watch the image sheet video before exploring the concepts in this video. In case you haven't worked with image sheets, you might be wondering what an image sheet is. Imagine it as a sheet of paper on which you draw the individual frames of your animated objects. Texture atlas, image map, or sprite sheet are also familiar terms you may have heard of. In Corona, it's simply referred to as an image sheet because its usage is not limited to either static or animated objects. You can, and often should, use image sheets for both purposes: static images picked from a portion of an image sheet, and animated sprites utilizing multiple frames from a sheet. In this video, we'll focus on how to use image sheets for animated sprites. For detailed technical notes and usage examples, see the graphics.newImageSheet API located on the Corona Labs website. To get started, let's look at an example. This image sheet of a running cat consists of 8 frames in a specifically ordered sequence. By default, the animation will begin at the top left frame, proceed to the next frame to its right, wrap to the next row when it reaches the end of the current row, and finally stop or repeat when the entire sequence is complete. The individual frames have been color shaded for instructional purposes, but the production image will not be. To configure this image sheet in Corona, first set up an index table for a basic image sheet of uniform size frames. To learn more about how to set up an image sheet using frames of different sizes, see the documentation located on the Corona Labs website. You can define animated frame sequences in 2 ways: consecutively and non-consecutively. Consecutively uses a starting frame index and frame count. Non-consecutively uses a specific order of frames. This makes the Corona Sprite system very flexible because you can use the same image sheet for multiple animation sequences. In both cases, you'll need to define your sequences in a comma-separated array of subtables. You can also mix sequences by combining both consecutive and non-consecutive sequences within a sequence table. Once we have defined our animation sequence, it's time to declare our sprite using the display.newSprite API. The syntax is simple: display.newSprite and 3 parameters. Parent is the display group in which to insert the sprite. This is optional. Image sheet is the image sheet which the sprite should utilize. Sequence data is the array of animation sequences which you set up. The sprite will default to the first sequence in the array unless you specify otherwise. We'll talk about sprite control methods in a bit. Keeping with our example, the sprite declaration should look like this. The sprite is now a display object, just like static images, vector objects, etc. It can be moved, manipulated, linked to a physics body, and so on. To remove a sprite object, simply use object::removeSelf or display.remove with object passed in as a parameter. Don't forget to set the reference to nil after removal. With our animation sequence defined and our sprite object created, we're now ready to make things move. The sprite system provides 4 key control methods which you'll use to control the playback and sequence for your sprites. They are animation play, animation pause, animation set frame, and animation set sequence. Animation play starts the animation playing. Animations do not begin playing when you create them. You must start each animation manually using this command. Animation pause pauses the animation. There's no stop control method, and instead pause the animation using this method. Animation set frame with a parameter of frame immediately sets or skips to the indicated frame index. If you want to stop and reset an animation sometime after you've started playing it, use the pause and set frame commands consecutively, setting the frame back to the beginning of the sequence. Animation set sequence with a parameter of sequence sets the sprite to a specific sequence that you declared in your sequence array. For example, if you want to change your cat animation from normal run to fast run, you would use the animation set sequence and pass in fast run, and use animation play to begin playing it, since the animation will not play automatically after you change the sequence. Now let's put the entire animation together. To set up your cat animation with two animation sequences, normal run and fast run, your code should look like this. If we test our project in Corona Simulator, we see the results. The cat appears in the center of the screen, animating on the normal run sequence. Since we didn't specify a sequence, the cat defaults to the first sequence in the sequence array. We can experiment with changing the sequence by typing animation, set sequence, and passing in fast run as a parameter on the line before animation play. Corona provides several properties which can yield information about existing sprites. You can even modify the relative speed of a particular sprite. These properties are frame, is playing, num frames, sequence, and timescale. Object.frame is a read-only property that represents the currently shown frame index of the loaded sequence. This does not set the frame. Use the :setFrame command to explicitly set an animation frame. Object.isPlaying returns true if the animation is currently playing, false if it is not. Object.numFrames is a read-only property that represents the number of frames in the currently loaded sequence. Object.sequence is a read-only property that returns the name of the currently playing sequence. Object.timescale gets or sets the scale to be applied to the animation time. This is used to control a sprite's animation speed dynamically. For example, a time scale of 1.0 is the default and runs the animation at normal speed. A time scale of 2.0 runs the animation twice as fast. A time scale of 0.5 runs the animation at half speed. The maximum allowed value is 20.0 and the minimum allowed value is 0.05. The value supports up to 2 decimal places. And that's a look at how to create sprite animations in Corona SDK. Learn more about using Corona SDK at coronalabs.com/university.